Hello, welcome back. In this video, we discuss about an important topic in metrology, limit fit and tolerance. We start with the necessity of limit system in manufacturing and the associated terminology of such systems. The necessity of limit and fit system arose from another term known as interchangeable manufacture. It has defined as the follows. The interchangeable manufacture implies that the parts that are for practical purposes identical, they are made to specifications by processes that ensure that they are so nearly identical that they will fit into each device of the same type. For example, we consider a nut and bolt of size M10. We know that M10 means it is a metric standard thread, and 10 means the major diameter of the thread is 10 millimeter. So the nut and bolt is there. So this is actually made according to the standards, and we know that a nut purchased from any shop in anywhere in the world should match with a bolt of the same M10 bolt which has been purchased from any other shop in anywhere in the world. So that is interchangeability. So the dimensionally these are made to identical or nearly identical. That is the very important thing, nearly identical. So how we will make this nearly identical? By implementing the system of limits and fits. Limits and fits. So that is the importance of limits and fits in manufacture. Consider some other examples of interchangeable manufacturing. Bottle caps. So bottle caps of same capacity has to match with any of the bottles. And the rims for a particular size should match with any of the vehicles. And of course, of the tires, these tires of a particular specification should match with any of the rims. So these all are actually requiring interchangeable manufacturing. These are very few examples, but a lot of things in a world or machineries are actually manufactured with this interchangeable feature. After discussing the necessity, we are moving to the terminology of limits and fits. So in the terminology, first we will start with the size. So simply, what is a size? So simply we can tell that size is a number expressed in a particular unit in a measurement of length. Okay, but in limits and fits, the base we start with basic size. Okay, that is the important size we need to start off. So basic size is the size based on which the dimensional deviations are given, because in limits and fit system we are not sticking to a particular size because of the limitations of the manufacturing process. We know that in a manufacturing process it is not possible to make all the produced work pieces. Maybe it may be hundreds, or it may be thousands, or 10,000s, or millions, or billions in numbers. We can't fix to manufacture to a particular size. We need a variation in size that is easy to manufacture. So from which one we are giving this variation or otherwise deviations? So that size is the basic size. Based on this size, actually we are giving the deviations. So in this figure you can see that this is a shaft. Only we are consider this shaft. See, shaft size is actually allowed to vary between these dark bands. That means it can be this size or it can be this size. Okay, this much variation is possible. This is actually a magnified picture, but this deviation is possible. But even though this is the deviation, but the basic size should be somewhat some size which is rounded off to nearest that one. So that is the basic size. Next is actual size. So actual size is the size of the component by actual measurement after it is manufactured. It should lie between the two limit of size. Limit of size we will discuss later. So the actual size is nothing but the size of a particular component which has been measured after manufacture. Next in the terminology, we will discuss about what is a hole and what is a shaft. Because in limits and fit system, very often we will use these terms hole and shaft. So hole refers to diameter of a circular hole as well as to any internal dimensions of a component. So it is not necessary to be round or as a hole, circular hole. It can be any internal dimension of a component that will be referred as hole. That may be a groove, that may be a square hole, that may be a triangular hole, or it can be a recess, etc. Okay. And similarly, shaft is all external features of a component, including those which are not cylindrical are designated as shaft. So a step on a surface of a material or what a square shape projection, everything is coming under the term shaft. Another term is the limit of size, limits of size. That means we are already discussed that we are not fixing a particular single size for a component. We are actually providing a possible deviation. So if possible deviation is there, there is some deviates from where it is starting, from where it is or at what position it is ending. So that is very important. So that is known as the limits of size, and we have got two limits of size, that is maximum and minimum permissible sizes of a part. And the minimum limit, we can see that this is the minimum size permitted for a part. That means if the part is made within that size, okay, that is acceptable. If it is gone beyond that size, it is rejectable. Then similarly, the minimal limit, it is the minimum size permitted for a part of a size. And here it is the maximum size. And in this picture, you can see that this orange color zero line is representing the basic size. Basic size is represented with a line in graphical representation. Then that baseline is actually representing the basic size, otherwise known as a zero line. Okay, this line is the zero line. Then we can have two limits. This is another way known as lower limit or otherwise minimum limit. And we can have an upper limit or otherwise we can tell that this is the maximum limit. So in actual practice, this is the basic size. Okay. And that means in example it is given as diameter 28, that is the basic size, but it can be varied, that is minimum to be up to 27.8, that is also acceptable. It can be increased to 28.2, that is also acceptable, because this is the allowance given for the dimension. So in manufacturing, we have got a freedom that we can manufacture any size between these two limits. If we have got these two limit of sizes, that is the maximum limit of size and the minimal limit of size, then definitely there will be a term known as tolerance, because tolerance is a term generated from these two limits of size. So tolerance is the difference between maximum limit of size and minimum limit of size, or otherwise maximum limit of size minus minimum limit of size is the tolerance. So in this example problem, we know that the minimum limit of size is 27.8 and the maximum limit of size is 28.2. And the difference is, we know that it is 0.4. So in this example, the tolerance is 0.4. Tolerance can also be expressed as plus or minus 0.2 because here the basic size is 28. So the lower limit is minus 0.2 from the basic size and the upper limit is lying at the plus 0.2 from the basic size. So it can be written as plus or minus 0.2. We can have different types of tolerance such as unilateral tolerance. See, in this unilateral tolerance, it is defined as the method of presenting limits. Both limits of size are in the same side of zero line. Okay, so we can we can discuss it with this picture. So this line is the zero line. Zero line represents the basic size. So we know that in tolerance it is now a band-like thing because the lower portion of the band is the lower limit and the upper portion of the band is representing the upper limit of size, and in between that bandwidth is actually representing the tolerance. If both the lower limit and upper limit are lying on the same side of the zero line, see in these two cases you can see that these two tolerance bands are lying at the top portion of the zero line. Top portion of the zero line means this is the positive side, and in the other two examples here and here we can tell that these are lying below both the upper limit and lower limit of these tolerances, that is this top line and bottom lines of these tolerances are lying below the zero line. That means both are in negative side of the zero line. Then these kinds of tolerances are known as unilateral tolerances. On the other hand, we can have bilateral tolerance. That means here one of the limits is on one side of the zero line and the other limit of size is on the other side of the line. Here this is the typical example. This is the zero line which is representing the basic size, and you know that you can see that in this picture the top side, that is the upper limit of size, is actually lying at the positive side. On the other hand, the lower limit of size is lying on the negative side of the zero line. So in the same tolerance bands, one size is above the zero line, one size is below the zero line. So that kind of tolerance are known as bilateral tolerance. The remaining terms of limit and fish system will be discussed in the next video. Thank you for watching.